All right, Mr. Ahmed here for 2.1 Part B. Goal for today is still working with our conditional statements, and we are going to insert some symbols for the conditional statements that kind of make these a little bit easier and shorter to use. So, for a conditional statement, if I have original, conditional, and if-then form, we would say P then Q. Okay, so if P then Q. So whatever P is, that's the hypothesis. Whatever Q is the conclusion. So in this case, the phrase immediately following the word if, that is P, and the conclusion is Q. So if P, the arrow means then Q. All right, converse. Remember, to write the converse, we take the original statement and negate both. Okay? Or sorry, converse. We switch the order. I made a mistake there. So for the converse, we switch. The inverse, we negate both. And the contrapositive, we switch and negate both. Okay, so that's how I recall those. So for the converse, for me to switch the order, I would take the Q and put it first and then P. So if Q, then P. The inverse is found by negating. The symbol for negate is a little squiggly sign in front. So I'd go back to the original statement and say not P, then not Q. And to write the contrapositive, I would flip these around. So I would say not Q, then not P. So when I look at the original statement, all right, P then Q. To write the converse, we'd switch it. Q comes first, then P. To write the inverse, we negate both the hypothesis P and the conclusion Q. And to write the contrapositive, we switch the order and negate both. So not Q, then not P. So we switched it. Q came first with a not. P comes second with a not. So using P and Q, write the symbolic statement in words. So P is the hypothesis. So that's whatever comes after if. So the sun is shining is my hypothesis. Conclusion Q, it is summer. All right, now not P. It is, the sun is not shining. Notice I didn't try and say that it's dark or anything like that. I insert the word not to do the negation. Not Q. It is not summer. We don't say it's winter. We just do the opposite and say it is not summer. All right. Now I'm supposed to write P then Q. Well, P then Q, that's the original statement. If the sun is shining, then it is summer. Okay, not P, then not Q. So negate both. Okay, negating both. If the sun is not shining, then it is not summer. And negating both, that would be the inverse. That's what I wrote there. I negated both. Now I'm going to switch the order. So this was the inverse. To switch the order, that's the converse. And to switch and negate the original statement, that would be the contrapositive. Okay, so the converse, switching them around. Back to the original statement. Here's my P, here's my Q. So if it is summer, then the sun is shining. And lastly, the contrapositive. If it is not summer, then the sun is not shining. And we have got all of these completed. So we can use these symbols to recall the converse, the inverse, and the contrapositive. We do expect you to know all of them. All right, on to our next part, truth value. The truth value is whether a statement is true or false. Okay, so we're gonna go back to 2.1 and identify if the statement was true or false. So back here a page, and we will start here with this one. If a polygon has 6 sides, then it is a hexagon. If it has 6 sides, it is a hexagon. That would be true. Okay? If a number is divisible by 2, it's even. Or was that how we wrote it? Well, we actually changed it around. Conditional statement. If a number is even, then it's divisible by 2. That is also true. Okay? This one's a little bit tougher. Original statement. If a number is divisible by 4, then it's divisible by 2. So if a number is divisible by 4, let's kind of think of numbers divisible by 4. That would be the numbers 4, 8, 12, 16, 20, etc. So 4, 8, 12, 16, 20, those are all divisible by 4. Are those also divisible by 2? I would say yes, they are even. So that first statement is true. Our original condition was true. The converse. If a number is divisible by 2, then it's divisible by 4. Well, I can think of something that doesn't work for that, and that's 14. 14 is divisible by 2, but not 4. So that is false. If a number is not divisible by 4, then it's not divisible by 2. Let's think about that one. If a number is not divisible by 4, then it is not divisible by 2. Again, I could look at my 14. 14 is not divisible by 4, but it is divisible by 2, so that's also false. 14 was my counterexample. And the contrapositive, if a number is not divisible by 2, then it's not divisible by 4. So if you can't divide 2 in it, you obviously can't divide 4 in it because it wouldn't be even. That one is true. All right, so let's see here. The original statement, the conditional, and the contrapositive were both true. And the converse and the inverse are both false. They will go together. Let's take a look at the next one. If 2 angles have the same measure, then they are congruent. If they have the same measure, then they are congruent. That is true. They'd both be 80 degrees, something like that. Converse, if 2 angles are congruent, then they have the same measure. Yes, if they're congruent, they'd have to have the same measure. That is also true. Inverse, if 2 angles don't have the same measure, then they are not congruent. That's also true. If they aren't the same measure, they can't be congruent. And the contrapositive, if 2 angles are not congruent, then they don't have the same measure is also true. So again, the first 2 were the same. The middle 2 were also the same. Conditional, contrapositive, both true or both false. The converse and the inverse are both true or both false. Take a look at one more case. Nah, I think we're good. We're moving on. So, a conditional statement and its contrapositive are either both true or false. And in a similar manner, the converse and the inverse are either both true or false. Okay? So they're going to be the same. A biconditional statement uses the words if and only if, and it is formed when both the conditional, so the original, and the converse are true. So if the original statement and when we switch the order is both true, it is a biconditional, which technically means it's a definition. So I write it using the words if and only if, which is abbreviated IFF. So we're going to check on a couple of these and see if the converse and the original statement are both going to be true. If that's the case, then we will write it as a biconditional. If it's not true, then we will not. Okay? So, first one says, if an angle measures 90 degrees, then it is a right angle. That is the original statement. Converse, switch the order. If an angle is a right angle, then its measure is 90 degrees. So let's see it. First statement. Is that true? If an angle measures 90, then it's a right angle. I would say that is true. Converse. If an angle is a right angle, then its measure is 90. That is also true. So based off this, we'd already know that the inverse is going to be true because it follows the converse. And the contrapositive also has to be true because it is going to be the same as the original statement. So all of them are going to be true. Thus, it can be written as a biconditional. So I'm just going to quickly wrap this up doing my inverse. Back to the original. If an angle does not measure 90 degrees, then it is not a right angle. We have negated both. Now to write the contrapositive, we'll switch and negate. So I'd start here by saying if an angle is not a right angle, then its measure is not 90 degrees. So since the original statement and the converse are both true, I can write it as a biconditional. Now when I write it as a biconditional, I can put the hypothesis first or I can put the conclusion first. It does not make a difference. So I'm going to say if an angle measures 90 degrees, IFF, if and only if it is a right angle. Okay, so that's how we'd write it as a biconditional, using the word if and only if, or IFF. So last one, conditional statement. Rewrite it. So a number is even if and only if it is divisible by 2. So let's see here. I would write that as if a number is even, as a if then, it is divisible by 2. And I would say that is true. If it's even, it has to be divisible by 2. That's true. And the converse, let's make sure that was also true. If it is divisible by 2, so if a number is divisible by 2, then it is even. That is also true. So it can indeed and was indeed correctly written as a biconditional. So all definitions can be stated as biconditional statements, and both the original conditional and the converse have to be true. Hence the word definition. That's all we got for 2.1 part 2. Have a good one.